All right. Hi, everyone. My name's Jon Schneider, and like Mike said, I'm part of the newfound developer insight team here at Netflix. We're kind of an offshoot of developer productivity that's working on finding ways to understand our code base and to affect change in our code base as it gets larger and it gets older. And so we're, 4 weeks old now or so, something like that. I'm going to give you a relatively early preview of the first two tools we have coming out of this space. One is on distributed Java source refactoring, and the other is on Gradle Lint, which we presented on earlier. But first, I'll give you a little bit of context about why these kind of tools are important here at Netflix. So first things first, Netflix has a freedom and responsibility culture. Hopefully some of you have read the Netflix culture deck. It's the most, I think, to me anyway, it was the most attractive feature about Netflix when I was considering it for employment. I think we have a belief that freedom and responsibility, which means basically that any teams can choose the technologies they want to use to a certain degree. They have different processes. They really do what works best for them in their particular business function. So we believe that it's a key to our innovation, that the best techniques constantly keep floating to the top. And I'm often asked, at conferences and elsewhere, about the seeming inefficiency of this. If you have, a bunch of different product teams that are all making different decisions about the tech stack they're going to use, and they're just making these little micro decisions, it seems like it can be inefficient. And while there is an efficiency to, I think, like a central design, and standardization across the board, there can be a built-in uncertainty about when's the appropriate time to change. So one thing I love about Netflix is you can guarantee there's always going to be some team that's pushing the envelope on the next technology, and maybe that doesn't work out, and that's okay. So we're always getting the best ideas being floated up somewhere in the organization. Unfortunately, for a developer insight team or developer productivity team, it also makes our job very challenging because we have a vast amount of variation in how our teams build and the tech stacks they use and so forth. So it's great. The things that we come up with should be very general purpose, I hope. The other interesting feature about Netflix, I think, is we're just now getting old enough to have old code. So while there is code here that's 10 or 15 years old, there's quite a bit that's been written in the last 10 years. And so we're just now kind of getting to the second generation of decisions on major things. For example, when the company had to originally decide on a dependency injection framework, like which one are we going to use in our platform? They looked around at the landscape. I don't know how many years ago that would have been, probably 5-10 years ago, and we're comparing Spring and we're comparing Juice and selected Juice and built some other tools on top of that. Built a class path scanning mechanism on top of that. And now several years later, while that served us well, that's showing its signs of age, and there's some regret now around some of those decisions, and we have to find a way to start moving forward, and that can be a huge challenge when we have this much code. For organizations, and there's a lot of them, of course, in Silicon Valley, the big ones like Google and Facebook, I believe Twitter as well, publicize their monorepos and how successful they are with monorepos. If you want to make a refactoring change across a monorepo, of course it's relatively easy. You've got all the code there, in one place. Netflix, unfortunately, is for this purpose anyway, is a binary integration organization. So our teams produce binary artifacts. They publish into a central binary repository, and code interactions happen through those binary dependencies. So there has not been a place yet where we could initiate a source refactoring operation and have it apply to our whole code base, split over a little over 1,000 Git repos. and have it take effect. So the kinds of changes, there could be a wide variety of types of changes you can make. If a product team is developing a client that's only used by a few others and there's only, say, 5 call sites, the change is easy, obviously. They make the change, they communicate to the relatively small number of individuals that are affected, and the change happens. When we encounter a problem like we want to make a change to an API and there's 500,000 call sites, the temptation is to not change at all, clearly. We have one such example of this that we're working with right now, which is early on, Netflix developed this library called ilog, or it's an internal Netflix logging library, one of many Java logging libraries. And of course, after that, SLF4J came onto the scene, and now we would all prefer to be using SLF4J, but there's something like 300,000 code references left to this old library, so it's very difficult to delete that code, to remove that technical debt. And at various times, different engineers have taken up the standard and said, okay, we're gonna kill this thing. They see those 300,000 references and they kind of think, it's not worth it. It's just changing a logging framework doesn't have a high degree of business value associated with it for the amount of effort we'd have to put in to make it happen. So ultimately, it just doesn't happen. And you can imagine when you have a bunch of decisions like this, each of which have relatively small business value, but represent some technical debt that can really accumulate over the organization. One thing I hear a lot when I talk to engineers about changing out an API that has a massive amount of call sites, there's always this temptation to say like you have this first row up here, you have it, some API, we'll call it new, and there's, let's say, 3 callers to it. Maybe each of those represents 100,000 callers, we'll say. And in the next row, they think, how am I gonna change this API? So what they do is, there's a temptation to just, we'll just hollow out the old API, and instead we'll just have it call the new thing. And so then, hopefully anybody that writes new code calls the new thing, and all those old 300,000 call paths just go through, the shim that goes to the new thing. And then you get to like generation 3, and now like you want to deprecate the new thing, and you wind up with 2 layers of indirection, and pretty quickly it becomes you just have a battlefield here of hollowed out APIs and that are difficult to reason with. So we don't want to do this, right? It's a temptation. We want to be able to change those initial call sites in a quick way. And just to reinforce this point, if I go and I hollow out the old thing and I write that new thing, that new shiny API, there's some concern that what I'm really doing is just creating a secondary standard that has to meet all the initial, the initial uses of that first standard, and so really we haven't gone anywhere, right? We've just made a more complex environment for ourselves. So sometimes, and again, when faced with problems at this scale, like how am I going to replace 300,000 ilog references efficiently? I hear often from people externally, not internally, well, maybe it's time for the culture to, you're going to have to grow up, right? You're going to have to give up some of this freedom and responsibility. Or you're going to become paralyzed. You're not going to be able to make change anymore. That skepticism is totally understandable. I do think that the lack of ability to distribute change in this organization is an existential threat to either our culture of freedom and responsibility or to our business, and neither is good for us. So here's what our goal is. I think as a developer insight engineer here, what I want is an eventually consistent monorepo feel for my developers with binary integration still. I want to have my cake and eat it too. And distributed refactoring is one of these things that's going to help us get there. So I mentioned before, first 2 tools, you're going to see a little bit of both. Still somewhat early on them. The first one is Java source refactoring. So this is a tool where we can use to describe refactoring operations programmatically. For each refactoring operation that you care to embark on, the emphasis is on building in auto remediation. So we're not interested in building a library that just emits a bunch of warnings in your build output. and even if those warnings told you exactly what to do, because we've discovered that deprecation warnings in the output result in very little change across the organization. It's never the right time to go dig through a bunch of deprecation warnings and and action them. So auto remediation is key. And lastly, and obviously, any tool that goes through and transforms code needs to be style preserving. So there's some challenges there. What we found is there wasn't anything out there yet that could do these three things together. So here's a small start to an example of how, let's retire this theoretical old logging framework right here. And these are the basic building blocks. You can create a source set from a collection of Java files themselves and a collection of the binary dependencies that those sources need. And then you can scan that whole source set. And what we're providing is an API to be able to affect change across each individual file. So the scan method is going to be called once for every Java source in this source set. And what we're saying is that we want to change the type of ilog to logger, wherever we see those. And we want to find method calls on that old ilog infof method and change them to the info method on the logger type. And we say we're done with changing that method. And then when we run fix, the code that underpins this source set will be transformed and done. So you can imagine running this against a whole project and changing the code then. So with the ability to write rules like this programmatically, how can we then take that rule and propagate the fixes? And the first thing that's packed into the Java source refactoring library is just a Gradle plugin. So a Gradle plugin that when you apply it, you can just run fix source lint, and those refactoring operations will take place. We'll see an example of that in a moment. We would like to build IDE plugins. I think the emphasis here is on finding ways to take these changes and surface them in the developer's workflow. We certainly don't want them to have to go to a separate tool, because again, it's never going to be the right time to go to that other tool and take these things into account. Annotation processors are another easy possible win, where you could use annotation processors to either warn in compiler output or fail compilation based on the presence of certain fixes that need to be applied. And then lastly, and something we've been doing the last couple weeks here, is we've actually ingested our source into our big data environment, and we can operate on the entire code base at once, and we'll see that a little bit as well here. So the first thing, the Gradle plugin. The intended workflow here is that a developer wishing to make a refactoring operation on, say, their library, maybe that's our platform core library that has this ilog class that we want to get rid of, that they would pack a class in that library with the auto refactor annotation here, and they just implement in that scan method whatever needs to happen to refactor. That ships out with a certain version of the platform core library, and whenever a team that's downstream of them receives that new library, they also receive the new auto refactoring rule. So that Gradle plugin, whenever you run fix source lint, just looks at your compile time or runtime class path. It looks for all the refactor operations available and runs them all. It's quite simple. So to ship a rule, when you want to deprecate a method, you don't just mark it as deprecated. You also describe programmatically how you want the end user to change and pack that with your library so that they're eligible for refactoring when they get downstream of them. The second approach I mentioned earlier, and this is something I think that can be recreated elsewhere, is we have a large Spark cluster here. We have a Zeppelin environment built on top of it. And the Java source refactoring library has a bundle that can be imported into that kind of environment. And if you can imagine somehow in getting all of your repositories to the point where they're accessible by that big data platform, and you can just operate on all those. So the first thing we're doing with that is just being able to do things like find method calls for ilog log event across our whole repo. But you could build a lot more sophistication here. You could say, find these method calls where some other condition is also true, you can imagine it's like a code search tool with a lot more expressiveness built into it. And of course, you could also perform the refactoring change here and then do something with those repos, issue pull requests against them, run an organization-wide diff, so you can, apply a refactoring operation theoretically, see what would happen to your whole organization when it takes effect. That's another option there. So as an example of what we can do with just diffing, if we had a few classes like class B and C, which both contain the same method, and A, which refers now to B, to this ident method. Really simple structure, snapshot it in your mind. We write a refactoring operation that just changes the type B to C. So instead of seeing new B, you would see new C. And then we run that fix. We can also, through the source refactoring DSL, capture the diff, and the diff would just return the get diff. So when we bring all of our code into our big data environment, you can imagine running, if there's a row for each source file and every source repo in your whole organization, and you basically create a new column that represents the diff of a particular refactoring operation, you could select over the difference in your entire organization all at once. That's a pretty cool ability. So before I transition to Gradle Lint, I think it's an appropriate time to see if there's any questions about Java source refactoring. Yes, sir.
I assume it uses AST transforms under the hood?
It's close. The question is it AST transforms under the hood? It parses the AST in order to discover the elements that you need to, that you want to change. But we don't emit the AST at the end, and that's how we make it style preserving. So we look at, if you're changing a particular method invocation, let's say, we look at the starting and ending positions of that invocation, and when we build up the result, we just substring to that point, put your change in there, substring after, and that's how it's style preserving.
Got it.
Yes, sir.
What is the output of your Spark job? Is it a diff? Is it a bit change? Is it a patch? Is it
Yeah, the question is, what is the output of the Spark job? Is it a diff? Is it a patch? Is it a, enter whatever you imagine? And the question is anything you want. So the scan method can return anything. In this case, this actually would compile because I would need a return statement here, but if the Java source scanner, it's a generic, so it's a type string, this would have to return a string right here. I could return the file name, and the file name could be, so I could just say these are the files that changed. It could be the diff. The fix could actually affect the code there in that local file system and submit a pull request before completing. So you can really just kind of do whatever you want. If I was just trying to count the references to a particular invocation, I just return an integer from it and map reduce from there.
by issuing a pull request? That's a good way for you to avoid conflicting commits from other members of the team, and that lets the guys review what your stuff is generating.
Yeah, and he's commenting again here on pull request being a good way of generating a mergeable difference here. And the pull request thing is interesting. I think there's a lot of asymmetry here amongst our teams as to whether or not they pull requests are a part of their normal workflow. So it'll definitely work for some of our teams, and for others it won't. Those pull requests will just kind of rot on the vine. And that's why we think it's so important that we have a bunch of different approaches. That for teams that like pull requests, you're going to get pull requests. For teams that are okay with it being surfaced in their IDE, it'll be surfaced in their IDE. If they want to see it in their build output, they can run fixed source lint as part of one of their, they can do like a precursor task to their actual release build. So it's going to just be, we're just going to give them a ton of options and see what sticks for every team, and hopefully develop more and more of them. Any other questions about the source refactoring thing? Yes, sir.
if you refactor something that needs to be refactored all across the board, how do you ensure that it's all done, and how do you revert back if something didn't work out?
Yeah, the question here is how are you sure when you're done? You know, I should have demoed this as well. One value of being able to execute the rule in our big data portal across our entire source set, you know, our organization source, is that we can take snapshots of the progress. Basically, we can know kind of re-execute this rule against all the sources and know how far along we are, and then start to break things down, group those repositories by ownership, and so perhaps everybody except for one organization, you know, has adopted the change. We need to, you know, communicate with that team and see what the difficulty is and what we can do to help. That's a key part of it. Yes, sir.
So some transformations, like on a logging framework, seem to have a good one-to-one mapping. But what about transformations where, you know, you've removed some of the arguments, or the semantics have changed and they affect not just the call but the code around it?
That's a great question. And let me mirror displays for a second here. I'm gonna have to do this anyway.
Arrangement.
Yes, I was right initially. So good, great. I presented a much simpler view of the logging transformation than is actually true. In our case, here's one such example where the original logging method had objects, or the arguments were string throwable object, and instead we need them to be like string object and put the throwable at the end. So even that's really possible. We can change the target variable, we change the name, and then we can start changing arguments. You know, we assert that the original argument names are this, and we reorder them. So that's a possibility. You can take a particular argument, like the first argument, which in our formatting mechanism we used like %F and %D. You know, those kind of formatting instructions. And SLF4J expects formatting to be curly braces. So that's another. You know, I need to actually transform the literal string of the first argument, and that's possible as well. So there's a catalog of the things, you know, these kinds of changes that we've needed thus far, and we'll just keep piling more on as we do more and more of these refactoring operations. But to date, there hasn't been. This one is pretty excessively complicated, actually, and we haven't found something we haven't been able to surmount yet. Yes, Justin. Uh-oh. Justin's a Netflix employee, so I was...
What about pieces of the source that have sort of secondary factors, like an import statement has to change?
Yes.
So only if you find it in one of these find method calls would you then maybe add an import statement. How do you sort of chain those two changes together?
The question is, how do you chain two things together, like add an import, but conditionally only if I take some other action? Some of the refactoring operations built in, like change type, already have that composite thing built in. So change type will say change foo to bar. If I'm going to change to bar, then obviously I need to add an import on bar. But I'm only going to add an import on bar if there's you know, references to foo that have been that pre-existed in the file, and I'll go ahead and remove any imports to foo as well. So some of that's kind of built in. Some of it, like at the very end, we just kind of get panicky at this point, where we're saying we just want to make sure there's no references to this thing left, even if we didn't consider why. Those kind of operations, if they're idempotent, they're idempotent. You know, it just won't change anything. So it's a combination of those things. Yes.
How do you make sure that this actually works? This, you know, it actually will fix all those 500,000 instances.
Part of it's just, you know, so when we run on Big Data Portal, we'll actually take that, we'll execute the refactoring operation and then bundle it up and ship it to a CI environment that we have to actually execute the build on that bundle. And so if you imagine doing that against 1,000 repos, we're just joining the results of that compilation as another table in that big Hive table that we're creating, and you can just select on things that failed, and then you'll know
Cool.
you'll know why. There's also a testing framework built into this, so you can quickly write unit tests based on pieces of example code, and you can assert that after refactoring operation takes place, that this is what it should look like. So it's a combination of those two things.
Nice.
What language is this? It looks like Scala.
Yes. What language is this? This is Kotlin. I was talking to some of you about Kotlin already. Plug for Kotlin. Great language. Yes, sir.
How do you communicate these changes to developers on other teams? Does it update documentation by itself?
Yes, so how do we communicate these changes? I think, again, there's going to be a lot of asymmetry because of the freedom and responsibility culture here. Some teams are going to like the pull requests. Some teams are going to want to put it as, like an extra build step in CI. Some teams are going to want to see it in the IDE. All of those things, and probably things we haven't thought of yet. But luckily, what we can do is we can put out a refactoring operation. We can watch the adoption curve and learn from that. In a few iterations, I'm sure we'll know.
It sounds like you have a procedure that the teams that are in charge of each repo is responsible for committing that in their own way.
Yes.
Do you also have, if you had Git repos that were orphaned or something, do you have automation around doing that commits on behalf of, or taking care of that piece yourself?
Yeah, and so the question is, if we have orphan repos, do we have automation around taking care of them? And I think at this point, I'm comfortable letting an orphan repo be orphaned, and not necessarily dealing with it. And I think so when we look at the metrics of adoption, that's just another factor we can take into account, which is when was the last commit on this? And we have a way of tying a source repository to their binaries and ultimately to whether it's deployed in a production or test environment as well. And so if there's a source repository that hasn't been committed to in a year and it isn't part of or a deployable somewhere in our environment, it's just a piece of trash that we'll let hang out there. Yeah.
So it looks like so far you support only refactoring of code sites. Do you plan to support other kind of refactoring?
Absolutely, yeah. So what other kinds of refactoring are coming up? Pretty soon we're going to have to be able to create new classes, create methods, inject statements into existing methods, things like that. So all these things are, it's just work. It's not necessarily hard to add at this point. So as we find a need for them, we'll just keep adding, just piling onto it.
As you're coming up with the recipe, it sounds like you'll have to do multiple iterations to get it right. So what's the turnaround time like from the time you start experimenting, running it on all your projects, getting results? So what is it like? Do you have some examples?
We're just getting to our, like I said, the team's existed for about 4 weeks now. We just ran our first test refactoring operation against all the source repositories today. We ran this operation right here that you're seeing on roughly 1,000 repositories. On that Spark cluster, it took 18 seconds to do it on 1,000 repositories. That's one of the benefits of going wide on something like that. In terms of the adoption time, I think it's probably going to depend largely on what kind of change it is. But we will see. Maybe we'll tell you in a future iteration of the developer experience meetup in Silicon Valley, right? Not sure what the exact title is. Yeah, great.
Yeah.
Any other questions on this piece?
Why Kotlin?
Why Kotlin? That's a large topic.
Why not Kotlin, I say?
I'll give you 2 quick answers, and then come talk to me afterwards if you're really curious. Null handling, extension functions, case classes. I said 2 and I gave you 3, but seriously, come talk to us afterwards. Or Danny in the back corner. We're passionate about that subject as well. So, great. So, real quick, you know what? I'm just going to hand it over. I think at this point we will. Gradle Lint is out there. Check Gradle Lint out. There's some talks on YouTube already about it, or I can demo that as well. That's just another refactoring tool that helps you transform Gradle code, which is you also think it's really hard to transform because it's imperative code, but we've worked through that as well. So that's it. Thank you.